Alright, so we're going to be learning about the solids of revolution, or the disk method today. So basically the disk method, what you're going to do is, if you have something like this line, like f of x here, how you would find the area between this on a set interval and the x-axis, you would set up an integral from a to b of f of x d of x, and that's the area between f of x and the x-axis. But if you want to rotate this thing to make it look like this, something like that, so something like a cone, then what you're going to do is the disk method. So it basically piles up circles or cross sections to make to find your volume. Okay? To find volume. And what you're going to do to find that is you're going to have so the area of a circle, its area equals pi r squared. So you're going to apply this formula that we have for the area of a circle to the integral that you would find to find the area between the f of x and the x-axis. So what you would have is the integral from a to b of pi r squared d of x. But you need to move this pi to the front, so the formula for a volume of a solid, or a solid of revolution, is going to be pi times the integral from a to b of f of x squared d of x. And that's your formula that you would use to find anything. So for the first example that we're going to have here is you're going to have, I'll move the thing. The volume of a solid created by f of x equals 2 rotated about the x-axis from 1 to 3. So you can see that. So the first thing you're going to want to do is graph it. So if we have 1, 2, so that's our f of x. 1, 2. All right, and then so it's going to rotate about the x-axis here. So it's going to look something like this. You're going to reflect it over the x-axis. So here's a -2, and it's going to be just like this. So it's going to look like a big cylinder. And there's all of our disks, our cross sections. Okay. So the first thing that you're going to do after that is you're going to set up the integral. So we got the integral from 1 to 3 of 2 squared, because that's our formula, or that's our f of x in this case, 2 squared d of x. So then you simplify this in here, so it's just pi of the integral from 1 to 3 of 4 d of x. And then, so this is going to equal pi times the antiderivative of 4, which is 4x, evaluated from 1 to 3, sorry, 1 to 3. And then you're just going to plug those values in for x, so it's going to be pi equals pi times 4 times 3 minus 4 times 1. So you got 12 minus 4 times pi. So your answer for this one would be a pi. And that's for an integral from, say, 1, 2, 3. So from here to there, roughly. That would be what your volume would be for that cross section, or for that revolution. All right. So then we got this AP problem. They're going to be a little harder, and so we're gonna try to find the volume of the solid created by rotating y equals 2x to the 3 halves over the x-axis on the interval from 0 to 4. So the first thing that you're going to want to do, just to make things easy, is you're going to graph it. So it's it's going to look something like a quadratic equation, because it's raised to 3 halves. So it's going to look something like that. And then it says we got to have our intervals from 0 to 4. So just for the sake of seeing what it looks like. So 4. So from there to there, and this is our area, and we're going to be rotating it, so you just reflect it So it's going to be this, something like that, something like a cone or something, whatever you want to call it. And then, so the first step again is to set up the integral. So our equation is pi of the integral of a to b of f of x squared d of x. So you just plug it in, equals pi, integral from 0 to 4 of 2x to the 3/2 squared d of x. And then you simplify what's on the inside, so you equals pi from 0 to 4 of 4x to the 3rd d of x. That's when you raise or you multiply times the inside, so you multiply by that, and then you multiply by that by 2 because you're raising it. So then you have pi. You take the antiderivative of this so you have pi times, what is it? X to the 4th, evaluated from 0 to 4. So then you just plug them in again, equals 4 to the 4th minus 0 to the 4th. Then 4 to the 4th is going to be 256 minus 0 to the 4 is 0, so pi. So your answer is going to be 256 pi. And that again is the area from here to here for 2x to the 3/2 from the interval from 0 to 4.